Hello everyone, I am Ashok. Welcome to the new video. In this video, it is discussing about the KVL and significance and sign convention. Some example regarding KVL. You are not subscribed to my channel, please subscribe to my channel and press the bell icon. Get notified as soon as possible when you upload the new video. Let's start the video. KVL. What is the full form of KVL? Kirchhoff voltage law. How can you define for a closed circuit the algebraic sum of voltage drop across a closed path is always equal to 0? What is the significance of this law? Law of conservation of energy. And move on to the sign convention. When you put positive and when you put negative, let's take one cell or a battery. When you move on to the negative terminal to positive terminal, that means lower potential to the higher potential. That means increase in the potential. So we put positive sign. Take another cell. When you move on to the higher potential to lower potential, that means decreasing the potential. We put negative sign. How can you find out the voltage drop across the resistance R and inductor L? I will consider negative sign and positive sign. So according to Ohm's law, V is equal to Ri. So VR, voltage drop, is equal to current into resistance. Current is I and resistance is R. We put positive or negative. Consider this sign. Positive, 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 positive. So these are same. We put positive sign. Let's move on to the another. I consider positive sign and negative sign. According to Ohm's law, V is equal to Ri. Voltage drop, VR dash, is equal to I into R. We put positive or negative. Let's compare with the current and voltage. This is negative, this is positive. So you put positive negative sign because of this is opposite sign. Negative and positive, this is opposite sign. See this. This is also opposite sign. So you put negative sign. Let's move on to the inductor. I consider VL, drop VL. This is positive, this is negative. So L is equal to not L, VL, drop across inductor VL is equal to I into di by dt. We put positive or negative. Compare this sign. Negative, negative, same sign. Negative, positive, positive, same sign. So you put positive sign. Let's consider another sign. Another VL dash. This is negative. This is positive. VL dash is equal to I into L into, this is L, sorry, L di by dt. We put positive or negative. Compare this sign. Positive, negative, negative, positive. This is opposite sign. We put negative sign. Let's some more examples regarding. I consider one resistance and passing the current 3 ampere and resistance 1 ohm and voltage drop is V1 ohm. This is positive and negative. I will discuss before. Entering the node is positive and leaving the node is negative. So compare the signs. Positive, positive. So you put positive sign. V1 ohm is equal to positive current into resistance. That means 3 into 1 is equal to 3 volt. Let's consider the another example of resistance 2 ohm and current passing through the 3 ampere. We know that Ohm's law, V is equal to I into R. I is 3 ampere and R is 2 ohm. When we put positive, I'll compare these two signs. Positive, negative. Negative, positive. So this is opposite signs. Put negative sign. V2 ohm is equal to 6 volt negative. You move on to the another inductor. of inductance L. L is equal to 2 Henry and current is 3 ampere. Voltage drop across the inductor is to find out minus plus minus. Let's calculate the VL. Compare this equation. VL is equal to I means 3 ampere into inductance. Inductance is 2. This is a current passing through inductor with time. So 3 ampere. This VL is equal to 6 volt. Positive or negative? Compare this. Entering the node is positive and leaving the node is negative. Compare positive, positive, negative, negative. So you put positive sign. Let's take another example. I will consider 6 ampere current passing through the 3 Henry inductance. I will consider V3 voltage drop positive. This is negative, positive. Entering the node is positive and leaving the node is negative. How will you calculate V3 is equal to inductance. Inductance is 3 into current. Current means 6 ampere. So is equal to V3 is equal to 3 into 6 is 18 volt. Positive or negative? Compare. Plus minus. Minus plus. That means opposite signs. You put negative sign. Take another example. This is both resistance, inductor and capacitor. How will you consider? I will take current I passing through the resistance, inductor and capacitor. Consider this is series, so we put I. This is VR, drop across resistance, VL is drop across inductance, and VC is drop across capacitor. I will consider point A and point B. Apply the KVL. KVL means apply this from A to B. VAB is equal to this. VAB is equal to drop across resistance, drop across inductance and drop across capacitor. I will consider VR. VR is a drop across resistance. VR, we put leaving sign. I will trick of this question is sign of the voltage drop is leaving sign. Which one is leaving sign? Negative. So put negative and move on to the inductance. Which sign is leaving? Negative. Put negative. VL, which sign is negative? Which sign is leaving? Negative. So VC is equal to 0. We will find out this type. Okay, I will explain some more example. Let's move on to the problem in this video. It is one of the gate question. In the given figure, we find out VAB, VBC and VCA. We first find out VAB. How to calculate VAB? To apply KVL in this loop, we get VAB. Let's try. We move on to this point to command this point. Let's take VAB. We move this direction. This is leaving side is negative, minus VAB. Then move on to this side. This is plus to minus. Leaving side is negative 2 volt. Then move on to this side. This is leaving sign is negative. Put negative sign with 1 is equal to 0. Minus VAB minus 3 is equal to 0. VAB is equal to minus 3 volt. Let's move on to another VBC. How to calculate VBC? Apply KVL. From this we get VBC B, C. This is a plus, minus, put a negative sign, then go on to this side, minus to plus, leaving side is plus 10 volt, then move on to this leaving sign is positive, plus 6, then move on to this, leaving sign is positive, plus 3, then move on to this, minus 1, then move on to this, VAB, put minus VAB, then comma this is equal to 0, minus VBC, 10 plus 6 16, 16 plus 3 is 9, 16 plus 3 is 19, 19 minus 1 is 18, 18 minus of minus 3, 18 plus 18 minus of minus, that is plus, so 3 volt is equal to 0, minus VBC plus 18 plus 3 is 21 is equal to 0, VBC is equal to 21 volt. We calculate VAC. VAC may be written as VA minus VC. I add and subtract the VB. VAC is equal to VA minus VB plus VB minus VC. That is VAC is equal to VAB. This may be written as VAB. This may be written as VBC. We get VAC is equal to VAB is minus 3 volt plus VBC. VBC is 21 volt. VAC is equal to plus 18 volts. This is the answer of this question. VAC. The question is VCA. So VCA, this is minus VAC. So VCA is equal to minus 18 volts. This is the answer for this question. On to the another question in this session. Given figure, we find out I, V1 and V2. This is V1, this is V2. How we will find out? First we apply KVL in this loop. I consider current I passing through this loop. I will first find out I. So you find out I will positive, then entering the node is positive, leaving the node is negative, then is positive, then is negative, positive, negative, positive, negative. I will apply the KVL. KVL is equal to, this is a leaving node is positive, plus 100, then minus I into 1, then positive 20, then negative 2 into I, then minus 60, then minus 3 into, this is I taken as V1, then plus 80 minus V2 plus minus. I will consider 3 into I. I will consider V1. V1 is equal to 3 into I. Then this is 4 into I is equal to 0. 100 plus 20, 120. 120 minus 60 is 60. 60 plus 80 is 180. 180. No, 140. Sorry, 140. 140. Then minus I, minus 2I, minus 3I, minus 3I, minus 3I. This is minus 6I, minus 6I. This is minus 6I plus 10I. This is minus 10I is equal to 0. I is equal to 14 amps. We find out V1 and V2. V1 is equal to I into R. V1 is equal to I means 14 into R is 3. V1 is equal to 14 into 3 is 42 volt. This is positive or negative? We compare this plus minus, minus plus. This is opposite sign. So put negative sign. This is the answer. V2 is equal to I into R. V2 is equal to current is 14 ampere into R 4 ohm. V2 is equal to this is 56 volt. Positive or negative? Compare this plus minus, minus plus. So put negative sign. Thank you for watching till